So imagine a chip which has 1 million transistors. You have to ensure that all 1 million of them are working. Now imagine the odds against you, right? One transistor goes wrong, it's a bug. And you spend $5 million getting the first prototype and it doesn't boot. Instead of hello world, it says bye bye world. That's it. Yeah, you're dead in the waters.
To make chip designers better, faster, but not necessarily out of a job.
Oh, I don't think that's possible. I think we are here to rule. He signed the docs and he said, if you truly believe in what you're saying, you shouldn't be applying to these universities. And right then and there, that's where I shred those documents. If the defense does not have a processor, if we are depending on foreign technologies from China, from Israel, from XYZ to procure these chips, deploy it in our artilleries, imagine what the war would look like.
Hi, this is Amrut. We are at IIT Madras, my alma mater, and India's top university for people who like to build. We are here to meet some builders, ask them, what are you building? What does it take to build? And what makes IIT Madras the best place to build? Hello and welcome to the Best Place to Build podcast. Today I'm sitting with Neel Gala. He's the CTO of InCore Semiconductors, a fabulous based out of IIT Madras. They are a Peak 15 invested DLI awardee company. Hello, Neel.
Hi.
Neel, a lot of our conversation is going to revolve around microprocessors. So can you broadly explain what a microprocessor is and then we'll start from there?
Sure. I'll probably start with what I was told when I was in 8th, right? A processor is basically the brain of any electronic device, right? It's what controls that device, how it communicates, how it interacts with the world in some sense, right? In very layman terms, it would be sort of a universal translator, which can sort of convert human intents, which would typically be written in code, convert them to ones and zeros, and make your digital world dance, right? So at the end, every single device that you think is smart or you think is capable of working by itself has a processor in it. And it basically fundamentally figures out what needs to be done, how it needs to communicate to the world, and how it can serve human intentions at its best.
Okay, so this now in the processor world, there are very few companies which actually build processors. They're all
True.
mega companies, NVIDIA, Intel, ARM. And in this pack of processor megamuts, India has developed this processor called the Shakti Processor, and you were there from day one.
Absolutely.
In the team that built Shakti. Yeah. So can you tell us a little bit about what the Shakti Processor is? How did that project start and how did you get into it?
Very nice. So I started my PhD, my master's program with Professor Kama back in 2010, 2012 timeframe. I always was excited about processors. I've done some projects before that, and it was something very close to me, and that's something I wanted to pursue as my research. What happened to be at that point was we did not have enough resources, funding, or access to the cutting edge stuff. Right? These companies that you named would give the tier 1 institute like IIT Madras access to at least 2 decades old of technology to do research on. That was pointless. And at that point, me and
Sorry, can I just understand this better? As a master's student, you wanted to work on microprocessors. You needed some tech from, say, an Intel or IBM or whatever.
Yes.
And you didn't have access to it because they wouldn't share their proprietary tech.
Yeah, definitely the geography played a bigger role. But also if...
Oh, they might share it with Stanford, but not with IIT Madras. Okay.
And even if they wanted to, we needed resources, right? We needed funding to do it, right?
Right.
So I always say this, right? Innovation warrants curiosity, but curiosity warrants funding, warrants resources, right? They have to come out of somewhere. And it just wasn't the right time at that point. And that's when me and Kama and a couple of other folks.
So I know you're calling him Kama, but you're talking about Professor Kama.
Yes, I will. I share a very close bond with him. I've spent more than a decade in his office with him on a lot of things. He's given me the liberty to address him. Hopefully I won't get a call after the podcast. But yeah, and that's when we decided if it doesn't exist, we should build it.
Okay.
Why not? Let's venture into that. So we started this effort. We started doing research on what's open, what's not there. My master's and PhD was now had to be on something different. I was looking at approximate computing. That was the gung ho at that point. But for this processor project, we started looking at PowerPC. They had something called Open Power. Now that's a funny thing because the name's Open Power, but you got to pay to have access to it, and it was more than 600 pages long, and it was almost to be sick.
OpenAI.
Yeah, I mean,
OpenAI.
what would you do with it? It's going to take me multiple PhD avatars to finish that book, right? And just around the corner.
One sec, sorry.
Yeah.
Can I understand that a little better? Open Power is a processor.
And yeah, so Open Power is an instruction set.
Okay.
An instruction set is the fundamental layer between hardware and software,
Okay.
right? So today you have two teams. You have people who build hardware and people who build software. They both can be independent, but they always have one language of communication. That is this instruction set,
Okay.
right? And that tells you how the hardware can optimize, and that tells you how the operating systems and the kernels and applications can be built.
Okay.
So this is the most fundamental. If this is broken, software is useless, hardware is useless.
Okay.
They won't talk to each other. And this became very important. And Open Power was an instruction set from IBM. We started looking at it, but it was it wasn't for academia to start on day one. It required a lot of ramp up. At the same time, we got some conversations going with Berkeley, and they released something called RISC-V. And Madhu was then a consultant working with us, my CEO. And he mentioned, why don't we look at this? It was very tiny. It was like 50 pages long. You could finish it within half a day and you could start implementing it. And they use this as undergrad courses. The point at that point was, because it was an undergrad thing, it kept changing a lot more often. Because every day they have to come up with new, problem statements, assignments. And Madhu sent out a mail to Patterson and the team over there saying, can you guys stop changing this? We are implementing this, stop changing the stuff. And that's when they realized that, there's other people interested in. In 2013, RISC-V was born.
Okay.
And we were adopting it before that. So that's how Shakti came into being. We said, we're going to ditch power. We're going to keep the name. That's how Shakti was called. Instead of power, we just translated it to Sanskrit and we called it Shakti. And that's how the genesis of Shakti was. That one day we decided we'll adopt RISC-V. We will continue on the journey of building indigenous processors. And this was all of Kama's vision, where he brought in the idea of if it doesn't exist in the country, we have to build it. There's no one else who's going to come and do it for us. So it was his vision, Madhu's execution, and reach out to working with Berkeley and trying to figure out what technology can be built. And I was just the hands on the ground trying to make.
So this is in the 2012, 13, 14 period where you were trying to figure out what to do. You've taken this side project where you're trying to figure out with this new ISA that's coming up. It's an open standard ISA, I'm guessing. Instead of working with ARM or a
Correct.
x86 or something like that. Then the Shakti processor that was going to be built at that time, what was the first goal? Like, what did you want to achieve first?
What we wanted to achieve first was parity. Parity with what India is already using or consuming at its marks, right? So we wanted to build a basic 5-stage processor. We started now reaching out to strategic sectors like the atomic energy, the nuclear energy, aerospace, defense, looking at what sort of process they use and can we start replacing that, right? So Kama, through his connects and through his influence, was able to get a lot of people on the table, at least have a conversation with, at least educate us on what is it that they do with these processors. So we started working with one of the DRDO labs. They wanted to replace one of the older MIPS access that they had, MIPS processors, and see if IIT Madras could do a better job at it. So that is the first win. That was in some sense to tell us this is what it's going to take for RISC-V to go commercial. This is what we want to build, something that's more real and less academic. So that was the first goal, just build something that people can truly innovate and use. Right. So Madhu brought in the commercial side of things, saying, don't build in vacuum. don't just put on the academic hat, go publish papers and come back and make this code useless. He brought in a lot more reality.
Product thinking.
Product thinking, right? That if you're going to build something, make sure it's usable. Then put on the academic hat on, what's possible beyond this.
And so the Shakti project, maybe I think the first tape out was in 2017-18.
Yeah.
So the next 4-5 years, you guys built, your team built this. Okay, it's amazing. I know that in the circles that are in the know, they of course know you as somebody who maintained the code for a while also.
Yes.
But eventually you sort of moved on and started this company called InCore, right?
Yeah.
So what does InCore do?
So InCore is in the business of providing RISC-V solutions.
Okay.
And by solutions, I want to emphasize that we are not just a core company. We don't build just the core, but we build subsystems, we build SOCs, and in fact, everything else that goes around to making a product or enabling a product based on RISC-V.
So, sorry. I have a question here. I want to unpack these words. So there's a microprocessor, there's a core. I want to understand what's the difference between a microprocessor and a core.
Okay.
Then you also mentioned a SOC, and then we said microchip. So subsystems, right? So can you just build it up? Like if I look at a final product like this
Correct.
This microphone,
what
is inside that?
So it all starts with the chip, right? And that's what you're going to get as a device from the fab, or packaged device, and you're going to solder it and build this chassis. Now inside the chip, there are going to be multiple components, right? One of the most important components is the core. The core is sort of the computational engine, the primary engine, right? And everything around it is a subsystem or a SOC, right? Let me give you an analogy, right? Since we are in campus, let's imagine the admin building at IIT Madras. That's the core. It makes all the crucial decisions. It's where all the data flows in. They decide what happens next. They have visibility into everything else, right? The campus is the subsystem or the SOC. You've got gates, which is basically how we communicate to the outside world, right? In-gate, out-gate, Taramani gate, and all of that. You have different peripherals like serial peripherals, USB, DDR, PCI. Those are all the ones that you can communicate outside. And then you've got hostels, which is where your data storage is, right? So you're going to have memory, you're going to have lots of storage spaces there. And then you've got departments, which are basically your accelerators or computational engines, where you can offload work. Now you've also got security personnel, which ensure that nothing goes wrong, right? Nothing bad happens, and they ensure that strict boundaries are met. And finally, you have the roads, which is nothing on how the data flows across all of these things, and that's the interconnect. So at a subsystem level, you're going to have the core, you're going to have peripherals which communicate, you're going to have networks which allow data to move around, you're going to have memory, you're going to have specialized accelerators.
Sure.
And you need to get all of these in order to build something.
In this, what does InCore make?
We do almost all of it.
Okay.
So we have the core. That's been our fundamental building block from day one. That's definitely our differentiator. But this core alone does not sell. People are not going to buy a core from me and go build their own chip. They're going to want everything together. And they would go to the guy who provides it. Right? That's how the world works. So slowly over the years, while we've maintained our core portfolio, we've also built these other ecosystem components, the networks, the controllers, the peripheral IPs, communications, and we've made an effort to ensure that you can mix, match, build any campus in rapid time. Right? So what people would do in 4 months, we should be able to do in a week.
4 months? That's also a stretch.
I wouldn't say so.
I mean, just give me an idea of that. Say a company like NVIDIA or Intel decides that we're going to make a new core on a new chip or a new system. For a new kind of phone, say. How long is that product development process?
So those are definitely of the order of years, right? When I said 4 months, it was just the design part. So this 4 months is where you come up with an idea. You're on the whiteboard, you've drawn something, you convert that to a spec, you then procure IPs, then integrate it, you modify it, you iterate on top of it, you verify it, you run software, you emulate it, and then it's ready for design, for physical design. That physical design process is much longer.
Right. So you get it to something that is working, say, on FPGA, and then again another process starts after that. Right. amazing. So I have this list that our mutual friend, my ex-colleague, and your current colleague, Deepak, has prepared for us. It says core IP, NOC IP, peripheral, security IP, accelerator IP. Yeah, so there's a lot of IP that you're building around all these things. Quick question. What is IP in this business, and how do you sell IP, and how does someone buy IP? How is it protected?
Okay. IP is, as it stands, intellectual property, and but the default definition would mostly just be, patents and copyrights that you have on something that you've created, you've ideated, and a lot of the industry depends on legal recourse to protect themselves. In some sense. But for me personally, I believe the IP at InCore, it's the intellectual, it's the productized intellect that exists at InCore, right? Can we think in terms of what we can sell, right? Not think in just pushing boundaries of research, not just building the next big thing, but it's unsellable of sorts. So yeah, the industry definitely piggybacks on IP as a way to protect itself. We encrypt them, we obfuscate them.
How do you? Oh, okay. Okay.
Yeah.
So I'll ask you, like, from the way I understand. Suppose I run a chip design company, say, and I want to buy your IP. What is it that you actually give me?
Great question. So we don't give you a physical chip. Let me make that sure, right? An IP company gives you softwares.
Okay.
So in order to build this IP, we use a lot of tools and languages, things like Verilog, VHDL. We use languages like BlueSpec System Verilog, Chisel, sort of things. We write code in that.
The code that you are developing in all these languages will go into my code?
Yes.
Okay.
So what we will give you is we will optimize, we will write this code super efficiently so that when you take this code to the fab, you get an amazing, low power chip or high performance chip and whatnot. That's the idea.
So related question on that, when you give me your IP as code, what stops me from just duplicating it?
So when we give you some IP, we definitely are aware of leak or security problems when it comes to giving it to our customers. We do some part of engineering there where we obfuscate the code so that it's not easily readable. We encrypt it so that you can't decode it back, you can't figure out the intrinsics of it. But these are all things to protect ourselves, but they make the life of our customers very difficult, right? Because they've put this IP into a bigger system, and once you don't have visibility inside it, they're not sure if the system is broken because of this or something else, right? So more often than not, you have to share source, right? Now the good part about InCore is we give them something called a Verilog IP. It's written in Verilog. Verilog is an industry standard language. As I said, we develop all of our IP in BlueSpec. So we develop all of our IP in BlueSpec System Verilog. Now that's a high-level language. That's what we keep closed. We convert this into Verilog, and we share this with our customers. Right. So this way, we've protected ourselves from the high-level stuff. We don't expose this out. That is truly our IP. That is truly something of our own secret sauce. We've built tooling, or we've adopted tooling, which helps convert BlueSpec to low-level languages. And that's what we make visible to our customers. So they have access, but it's going to be very difficult for them to reverse it.
This is common in the industry, right? Like,
absolutely.
I mean,
just make it difficult for people to break it, right? I don't think you can fully protect it. If anyone says that they fully protected their IP, it's probably unusable or they're lying. Right?
Is it easy to build an IP company in India?
Oh, absolutely not. I think it's the worst idea you could have to build an IP company in semiconductors, right?
Oh, not even in India, in general?
Yeah, in general. I mean, the economies are against you, the cards are against you, the amount of tooling and investment that goes in to build something of an IP is huge. And the returns are a long way ahead, right? The only way you can scale is through royalty or through building something of such high value add that you get paid in the orders of millions for a single IP, which is very rare that happens.
So, and I think we were talking before this interview started that NVIDIA and ARM are IP companies, right?
Yeah, they're fabulous chip companies, yeah.
Yeah, and I think they scaled because the chips they were making at some point scaled because of a particular use case. NVIDIA scaling because of the crypto boom. and ARM scaling because of the GSM phone boom.
Yeah.
So,
I was just going to add, each of those are, they're slightly different than InCore. We are still ahead in the supply chain. NVIDIA owns the chips that it gets manufactured outside of itself. It need not own a fab, but it definitely it builds the IP, builds the GDS, goes to the fab, gets the chip, and then sells the chip.
okay.
We basically provide an IP which allows customers to go build their chips themselves through the fab or not. And it takes massive cycles of iterations, of optimizations, and a lot of effort to realize that IP into a value add in the final chip.
Can I just come back to something you spoke about earlier? You said that the thing that you're focusing on is reducing the design life cycle, and you said 4 months, and I said maybe it feels like it should be more. Few weeks, few days. So what is it that what does that mean? How long is a design life cycle? How are you reducing it?
Amazing question. So we are in the phase of spec to RTL freeze, right? Design freeze. Okay. Now, when you want to build a chip, there are multiple phases. You start with a spec, you get the first design, then you start physical design, then you go to the fab goes to packaging, then you build chips, you build boards, and then you do a demo, right? This entire life cycle is at least 18 months. You could cut corners and skip a few steps and maybe do it under 12 months, but it's at least that much. Now, within these 12 to 18 months, it takes you at least the first 4 months. Just go and figure out what you want to design, right? You're going to start with, okay, I want to build a smart bulb, right? I want to build a chip for that. I want to have some intelligence into it. I'm going to need some USB. I'm going to need Wi-Fi. I'm going to need Bluetooth. I'm going to need some other memory devices and stuff. You build this nice little diagram. That diagram now needs to get converted to actual design. Someone has to go procure these IPs because you're not a design house. You don't build everything in the world. You go license it. Whether it works, it doesn't work. Someone else has a competitive part. You go buy that. You evaluate them. You see whether they get
the things you spoke about. Bluetooth is a protected IP. You can't, even if you knew how to, you can't design it.
You can't design it in day one. So then you've got the pieces together. You've basically now have a recipe, and then you start executing the recipe. You put it together. Now you got to check whether it works before you actually go to silicon. So you're going to have a software team which is deployed, and they're going to build a complete stack of the application, the firmware, the kernels, all of that stuff. Then you're going to have people working on emulation. So you're going to prototype it on FPGA so that you can see what the silicon would look like. How was it going to feel? Does it need timing? Does it need other parameters? And then there's a bigger beast of verification. Right? Am I sure that everything works? Am I bug free? And that's the intent of these teams. Each of these things can easily take 4 to 6 months, right? And the problem with the conventional way is they all start one after the other. They're serialized. You first have to get the design so the VERIF starts. Only when the VERIF starts, you can then put it on FPGA. It's only on the FPGA you can do software, right? So by the time your software team is kicked in, you're already 2 months in or 3 months in. What we're trying to do at InCore is we want to reduce this time period to weeks.
Okay.
Right? And within this week, what happens is you can iterate, you can keep changing stuff. We will give you collaterals for software, for hardware, for emulation on day one. So your teams are not just on the bench. They can actually start hacking as soon as possible, right? The biggest add over here is you still have 4 months, which means you can now focus more on your innovation, right? You wanted to basically put in your AI accelerator, but you needed a Bluetooth, you needed a Wi-Fi, you needed stuff so that the rest of the world works. Your value add, your innovation was in this accelerator. You got derailed by doing all these other things that the world does, and you spent 4 months there. I reduced that to 4 weeks or 4 days. I've given you back 3.5 months to focus back on your accelerator. So now you've got more liberty to innovate. And that's where InCore is going, right?
So the innovation cycle, like for instance, we talk about innovation cycle in software products. It's almost immediate, right?
Yes.
Like I remember a time when you used to buy Windows in a CD.
Correct.
And then wait for 1.5 years for them to release the next version or update.
Yeah.
And then there was Windows 95, which came in a CD, and then Windows 98. But today it's like a continuous sort of
patch,
evolution of SaaS tools, right? So from being very blocky 3-year innovation cycles, it's gone to a 0 almost overnight innovation
Yeah.
cycles. And what you're saying is that that equivalent process in chip design can now go from months to weeks because of what you're working on.
Yeah, I think.
Is that a
See,
correct
chip-
understanding?
Absolutely, absolutely. And the reason this happens today, it exists in the semicon industry, is the lack of the open sourceness, right? So software has seen an open source revolution. You have access to so many things. You have access to blogs and forums and ideas, and you could ask a question on Stack Overflow and you would get an answer in a day.
Yeah.
That level of expertise, that level of openness, that level of data sets just don't exist, and it's always a massive learning curve, right? So which is why I always say that today, building a chip is a marathon, and it's a marathon with a condition that you can't quit. You just can't step out because you've invested millions of dollars to see that first damn prototype.
Right. And that's not even the opportunity cost. You're talking about actual money.
Actual investment, that is the patient capital that this industry demands. I need 18 months of investment, no questions asked. And we are on a mission to make that marathon a sprint. I want people, I want engineers in the future to truly commoditize the thinking of silicon, right? Today, people innovate on software, they should be able to innovate on silicon the same way. They shouldn't just fear it and survive it.
That's a very
Because it's a
interesting
company.
point that I want to just focus on a bit. In software, the innovation cycle is so quick and the resource requirement is so less that if you come up with a prototype that doesn't work, you just junk it and move on. In silicon, junking a project is very tough because you basically
Bankruptcy.
yeah.
Close to a bankruptcy problem.
And if you're in a bigger company, that could simply mean that your team is going to be
Oh,
let go.
definitely. This industry is extremely risk averse. Right. There have been multiple instances in the past where large MNCs, right, who've been chip vendors and OEMs, had to recall millions of their chips, and that's the biggest problem, right? A single bug. So imagine a chip which has 1 million transistors. You have to ensure that all 1 million of them are working. Now imagine the odds against you, right? One transistor goes wrong, or one element or one gate goes wrong, it's a bug. And you spend $5 million getting the first prototype and it doesn't boot. Instead of hello world, it says bye bye world. That's it. You're dead in the waters. You got to restart. That entire cycle starts again. And
Interesting.
the aversion makes you a lot more paranoid. I want to make sure that there is no bug. I spend 8 months of verification cycles with as much confidence to say that yes, I have hopefully gone through anything that a customer would go through, any corner cases, and my chip will still work.
Very nice. I'm looking at Deepak's notes again. Thank you, Deepak. It talks about something called an SoC generator platform. So can you tell us about what this term means? And I know you're explaining the same thing, but can you sort of give it the, how do I go from that term? Like if I'm in the chip industry and I read SoC generator, what do I understand from it?
Oh, wonderful. As I said, the subsystem is much bigger than the core. Right? The core becomes the fundamental building block. But a subsystem or a system on chip, that's what an SoC stands for, is much closer to the end goal. Right? You've brought in all the IPs, you've brought in together. Now the problem is, every time you start a project, you're going to be using the same IPs but differently. Right? It's like a recipe, whether you add the salt first or the sugar later and jaggery, right? It gives you a different flavor and different trade-offs. The generator that we have built allows you to do those trade-offs at rapid speed. Right? I could go around, play around, change, and I could iterate and say, okay, if I mix these components in this order, do I get good performance? If I change the order or if I bring in something else, do I get better area? Do I get better power? And that's where the USP is. Right? So we've dealt with customers who have gone through 20 iterations in a matter of 2 weeks. Right? They started off saying, okay, I want to match this part from the industry. We gave them a solution and they said, okay, now can I optimize on this? Okay, 2 days, let's iterate that. We give them a new drop. Okay, that's good, but I've gone up in power. Can we go address that? Okay, let's do something else. This would typically take weeks of iteration.
You're saying it, but I think PPA is a
Power
term in the
performance
industry,
area.
right? So what does PPA mean?
So PPA stands for power, performance, and area. You have to be good on all of them. You need to be low power, you need to be high performance and low area.
Low power because you want to use lesser battery, which is obvious. Like on a smartwatch, it would mean a lot more time.
Absolutely.
And that's a feature that customers would. In fact, in a remote operation, you may want your chip to work for 5 years, 10 years.
Battery operated systems.
Performance means?
Mostly the frequency. When people tell you I'm running at 3 gigahertz and 4 gigahertz of processing power, that's basically how fast you can consume data, compute it, and infer it.
And area is the area on the silicon, which is directly correlated to price, right? So is it smaller the chip?
Smaller the chip, the smaller everything else. You got smaller BOM, your PCB shrinks, everything starts shrinking because you need less wires and stuff.
Fair enough. So like this is not a smart ring, but if it were a smart ring, then it would require a really
Absolutely,
small chip. This is in addition to the feature set.
Exactly. So now there's a feature set because I want Bluetooth and Wi-Fi and XYZ, but I need them for this power, performance, and area.
Right.
This translation can take months because you're doing it manually. Every time you want to shift a block, you have to edit 200 lines of code. You got to paste it somewhere else, make sure it works. We've just built a platform where making these modifications are as abstract as changing a YAML file. Right? You don't have to learn the language. You can just go write a form. And the tool is smart enough where it figures out what your intent is. It puts in the right blocks, puts in the right pieces. It doesn't just give you the design, but it also gives you other collaterals like verification. It's going to give you a test suite on day one, right? So you don't have to start from scratch.
So just to recap a bit, what you're saying is that traditional companies would have a requirement set, a PPA requirement, and then they would take maybe 4 months to go through the design cycles to build that. Maybe longer depending on how much money they have, how much resource they have and all that. The InCore SoC platform shrinks that 4 months to maybe 4 days or maybe a few weeks. And therefore the team can spend that extra time and energy that they have to sort of build a better product and so on. Is that correct?
Absolutely, absolutely.
So the immediate question I have on that is that why can't AI do it overnight?
Amazing question, right? If you look at where AI is being deployed in this industry, right, it is still a co-pilot. It's not something that we can completely depend on to produce an output which can be consumed without human intervention. Right? So it helps a lot with verification. So it helps identify corner cases, but because of the risk-averse nature of the industry, we still have to have humans in the loop. We still have to go through those iterations and regressions and confirmations whether we are actually doing what we set out to do, right? And this paranoia exists because of hallucinations in AI, right? That's a big problem. I don't know whether it's going to give me the optimal or not, right? So if we start deploying Gen AI or generative AI to these problems of building chip design, it's probably not going to take off too soon. But having said that, there have been learning algorithms which have been deployed in the industry over the decades. But these have been limited to the big companies like Intel, IBM. They definitely have much more smarter algorithms, smarter tools which look at their data sets and help their engineers produce better based on its own internal learnings, right?
Okay.
But does a startup like ours have access to that AI? Do we have access to that smart tool? Definitely not. That's proprietary.
So you're saying that Intel has 40, 50 years of designs. It can train an internal tool on those designs to generate future designs,
Correct.
which may or may not be accurate or reproducible. Yeah. But in any case, the rest of the world doesn't have access to that AI, which
you can't just take GPT or the O3 model or the Claude models because they have not been trained enough. There's just lack of training data sets in the open source world, which tells you how to do the best designs out there. A lot of it is academic effort. So you have to know that if the AI was trained on academia, it's going to give you an academic output.
Right.
To productize it, you still need the people there. So it's going to be a long way off, and hallucinations don't make the cause better. Reproducibility makes it even more difficult to rely on AI. But as you said, AI can always be used as an interface to the SOC Gen 2. That's something that we hope to work on in the next couple of months is, can you give me a prompt which converts it to an input to this tool? But the tool does the generation. The tool is what creates the SOC. I would use the AI to analyze the inputs and outputs to the tool, but never deploy it to generate the SOC itself.
Sure. So it becomes like a co-pilot, which is what you started with.
Which is what I said.
To make chip designers better, faster, but not necessarily out of a job.
Oh, I don't think that's possible. I think we are here to rule quite some decades before AI takes over our jobs.
We being chip designers.
Yes,
Nice.
that's my motivation to all freshers to, join this industry.
Nice. Yeah, I think, sorry, just to pick on that, the semiconductor industry or the talent pool in India is actually growing very, very fast. We talk about how people are choosing to be engineers less now compared to, say, 10 years back. That is not a problem that the semiconductor industry has. It's the opposite problem.
Yeah, we definitely, and thanks to a lot of the government initiatives and focus on the semicon industry, as you rightly said, it has definitely changed for the good. I think what's also happening is ramping up curriculum. I think we need to do a leapfrog there as well. We need to get onto new technologies, stop doing old stuff, stop teaching old styles. RISC-V should be the mandate, for example. Right.
Before going to RISC-V, just a little bit more on this talent pool issue. India has always been rich on electronics and semiconductor engineers, right? But more often they just migrate out of India. And you told me of a very interesting and exciting story of you and a paper shredder.
Yes.
Can you tell us that story?
Absolutely. So this is while I was working with Professor Kama as a project staff, and
That would be what?
this was around 2010 time frame. I'd graduated in 2010. 2011 is when I was like any other peer of mine. I was behind the American dream. Let's go do masters there. I started applying. I had this list of 6, 7 universities, ambitious, moderate, backup universities. At that time, we had to write recommendation letters by hand. And the prof had to sign it, and we had to courier it.
Yeah, and Professor Kamakoti's recommendation letter carries a lot.
Oh, definitely. Yeah, it was, and I was, I would do anything to get that letter. So I one fine day, I had 2 more universities, which were my backup universities. And I was waiting for him in his office. He comes out of his office at close to 8 p.m., right? And he tells me, Neel, what's up? And I tell him, I have these 2 universities. You've sent 6. Why don't you send these 2? These are my backup. Why are you going there? I mean, these are backup. These are even worse than doing a master's in IIT Madras. Why do you want to go there? Why do you want to abandon your parents? I was like, no, I will come back for sure. I was like, nah, if you want to come back, then why go at all? Maybe what can I not give you that these universities are giving you? That made me realize this is a prof I spent 18 months with. He sees the potential in me. He believes that I can do much better here. And yet I'm on this wagon to go try my luck out in a foreign land with foreign people with zero idea of where my future is. And that very instant, he always keeps a shredder because he does a lot of confidential stuff there. He signed the docs and he said, if you truly believe in what you're saying, you shouldn't be applying to these universities. And right then and there, that's where I shred those documents. I stopped applying. Fortunately, his recommendations gave me access or gave me admissions to an Ivy League school as well. But Professor Kama is a force of nature, right? It's impossible you walk out of his room with less patriotism.
Yeah, it's very inspiring.
You're just filled with heart of patriotism, and it would be very tough to, wean that off. And that day forward, I think we were aligned on, the belief that India has to create and not just consume, especially on some of the most fundamental technologies of the digital era.
And this is, of course, before the Shakti project started. So after that, you guys collaborated.
Yeah, then it became sort of, we doubled down on each other, right? He was the axis, he was the guy with the vision. He would convince the government strategic sectors to, talk to us, to work with us. And he was able to make a call. Before Atmanirbharta became a norm, he was literally driving it for us, saying that if the defense does not have a processor, if we are depending on foreign technologies from China, from Israel, from XYZ to procure these chips, deploy it in our artilleries, imagine what the war would look like.
Yeah.
And that's enough to set paranoia in some of these sectors. And that's how Shakti truly took off. It started off as a mission to satisfy indigenous requirements first.
Yeah. If you say it like that, it's a very scary thought that our power plants, our grid systems, our CCTV cameras,
Your Aadhaar card. Your
Other
banking
database, your banking database runs on infrastructure built on chips. Maybe these are chips that we trust the vendors from, but sometimes maybe not.
It's mostly not because of how technology is. You can't reverse engineer a chip. If I give you this, okay, this connects to WFI and Bluetooth, I tell you that.
Fair.
But I
Nice.
can't tell you what it does not do.
That is correct. If you have sold me an IP which is encrypted and I can't look at it anyway, then I don't really know if it has some kind of a backdoor entry.
Yeah. And you have a requirement to satisfy because you're a nation of 150 crores. And it's unfortunate that the lives of all of them depend on technology that was not born in India, not known to India, and can't be probed by us. So it's definitely scary, and which is why an effort like Shakti has answers to some of them, but we definitely need much more broader acceptance.
Okay, so in your journey, you have worked a lot on the Shakti ecosystem. I mean, congratulations on reaching so far. The Shakti process ecosystem has also inspired a bunch of startups, yours included. You've moved on from just being the Shakti, the person who was heading the Shakti technical group, to now being the CTO of InCore. InCore itself has moved on to being a IP provider company across a bunch of things, and now you are betting on this SOC generator idea, which is shortening the design life cycle for a bunch of chip companies, right?
Yes.
Okay, that's
It's a short brief.
lot. I want to ask you, in this process, you've gone from a researcher to a sort of a researcher working on a product to a technical co-founder, and that's a journey in itself, right? Because you're now
Absolutely.
running a business.
Yes.
It's a difficult business, but it's still a business.
Absolutely. Yeah.
So how has that journey been?
It's been an uphill for sure, right? Once you've been in academia for so long as doing a PhD, I mean, I spent more than a decade in Rise Lab, and it's a comfortable space. It's very tough to get out of that space because karma spoils you. He will give you all the luxuries in the world, all the access to everything, and it's you simply start believing that tech is the answer to everything. If you build a tech that should solve all problems in the world, and that's where we get it wrong. Right, the transition. So what academia teaches you to think is what's possible. What entrepreneurship demands you to think is what's needed. Now, I was lucky that I was at the inflection point where the answer to both of them was RISC-V or Shakti, and I could connect the dots. But when I switched on, when I put on the entrepreneurship hat, when I became a founder and a business owner, listening to the customers, trying to understand their pain points, because they can't be as articulate as you would like to be, right? You truly have to probe them enough. You have to sit with them in the same room, and then realize that this is a problem which requires a much different solution than what I'm doing. Now, there are two ways. You could always say that, okay, I'm not going to do this because I've built tech for something else. But if you could take 2 steps back and said, if I make some changes and if I can address this, then this market opens up.
Sure.
So the ability to listen, right? You need to sell before you build. That's a very difficult thought process to an engineer. For a good part of my journey, I was scared to go sample with customers until I got it perfectly done, right? Because I would come up with my corner case scenarios. I would cook up things that could go wrong. I would start fixing them. And I would keep telling Deepak, no, one more month. No, 1 more week. I just need to do this. I just need to do that. But at some point, we put a foot down and we said, wherever it is, let's just throw it over the wall. Let's see what happens, what breaks, right? Amazingly, it was a very different response than I expected. People were warm to it. People wanted to see how we could do things differently because they saw value add even otherwise, right? So for anyone who is making this transition, I would suggest, stop thinking that if you get the tech right, the job is done. The job only starts when you know what needs to be deployed and what is sellable.
Very nice. I'm reminded of this story, really old story of how Bill Gates sold DOS to IBM before they built DOS.
Yeah.
And then they were very convincing, and IBM said, sure, let's buy it.
And this industry is exactly that, right? I've been saying this multiple times over this, that to build a product, it takes 18 months. Imagine you were on the wrong path of building the wrong product. You've got to start again. And that first customer, that first interaction to the outside world is absolutely important.
So going from an academic setting where you're working on the product, where you're building something, where you're focused on the output, where you're focused on academic milestones or product milestones, to being a business owner where you're focused on more your customer, their needs, the available money pool, that, I mean, what they're willing to pay for.
Correct.
Those are things that you, as a business owner, you would have had to learn, right?
Yeah, I think a customer doesn't just bring money to the table. I think they bring a lot more value add, because in this industry, people will bet on you if someone else has bet on you. So it's very difficult to get the first customer, because you are a startup who has just got the first tape out done, first silicon of your own, but no one else has actually deployed it. No one has placed.
I have heard a word called market proof,
silicon proof.
silicon proof.
Yeah, market proof, silicon proof. So someone should have placed a bet on you, so that others can. And finding that first guinea pig, finding that first customer who truly wants, who believes in
And is
theory.
risking a recall, basically.
And at that point, you are selling your soul. You're doing everything possible, right, for that one customer. He tells you to build a quantum chip. You as well start learning quantum the next day, because that's the one thing that will make your third, fourth, fifth product sell at a rapid pace, right? So that's a very different mindset. That's a very different way, and you have to be fluid to adjust to market trends.
Nice.
If you start off saying, "Oh, I'm going to build this big ass processor or this tiniest core," that's a bad thing to do, right?
Neel, also in this journey, you have raised funding.
Yeah.
You have investors backing you up. You're a DLI awardee.
Yes.
And that means you have to not only listen to your customers, but also to your investors and the government, which for good reasons may want to take a direction, may want you to take a direction that's not aligned to your customers and so on. So is that also a journey that you have had to?
Oh, absolutely, absolutely. I think so. Once we got invested by Peak 15, they have these surge sessions where they take you around meeting with other eminent personalities in the field, as founders. One of the investors mentioned that as a founder, you're constantly selling. Whether your every waking minute, you are selling to your employees that you're a good company to be in. You're selling to your investors that they've invested the right place. You're selling to your customers that you're the right piece of product to buy. And managing this is chaos, right? Because as you said, I would have spent a couple of years building a product, and the customer wants something different and they're willing to pay upfront. Now, do I make the decision to give up this? Because I do see potential, but that is the first customer which requires us to go in a different direction. And you got to make a call. That's where, people like Deepak and Madhu would come in, and they would say, what does the market look like? What are the trends? And that's where you stop being technical and you say, stop thinking of engineering hours, think about the company first, right? Stop putting yourself as the guy who needs to implement it rather than the guy who needs to sell it. And that makes life a lot more clearer, right? So managing expectations is definitely difficult. People have pushed us or pulled us in different directions. I can tell you, one of our initial, customers that we were talking to, they spent a lot of time with us but didn't materialize, right? And we thought we could win them over with our tech. And what we didn't do was, we didn't get enough guarantees from them saying that, they will actually go to market, they will actually deploy this. And these are learnings that help us. I don't think there is a shortcut or there's a book which tells you don't do this and do this. I think every journey is of their own. And
actually, even if you knew that, you're going down, you're being led by a larger player down this path, at the moment you're very small, you don't have as much bargaining power. Like, you can't go and tell a large company that I want this in writing.
Absolutely, you can't do that. That's the fear you have. But if you make that demand and they don't have a rationale behind their answer, they should throw up red flags, right?
Yeah.
So I think it was the fear of not attempting. I think the fear of failure is so high with us, we don't even attempt to ask those questions. It's okay to be thrown down. It's okay to be told you're small. You are small, right? No harm in accepting that, but you don't want to hear it. And those are the mindset changes that you need to make. You should be okay in people telling you your reality. You being cognizant of where you are and where you need to be. That's very different than writing code.
The advantage you have though is that the product you're building or the IP you're building is globally scalable.
Yes.
Right, and it's not a location specific thing. So once it starts picking up and once your first big clients come in, and I don't know how close you are to those kind of milestones.
Right.
But then in semiconductor in general, the scale happens very quickly. It happens.
Absolutely.
It takes a long time, but once it happens, it's very fast, right?
Absolutely. It's the first customer is the toughest one, because he's the guy who's taken the risk, and he becomes your well-wisher if he's happy, right? And that well-wisher is gonna close deals at half the speed than you can imagine, right? If it typically takes 6 months sales cycles today, as in core, post our first customer wins, couple of wins that we've had, now the sales cycles are like 2 months, a month, because they know someone has taken your IP, gone to product, they've made money out of it, and they've not complained. These guys want the same stuff, or they want something more modified. Now they have confidence that InCore is really a semiconductor company to scale. Now, when it comes to being global, the space that we are in, InCore is in, we are more of, I don't think India is the right market today. I think we are a little ahead of time. Right now, the wave of in the Indian semicon sector is mostly on chip designers. Right? You're going to find a lot of companies and products who will actually sell chips. This is the first wave, and this is by design, because of the kind of incentive schemes that the government has come up with for fabs, for OSATs and stuff like that. So people have been pushed to build products first, right? No matter what it is. I believe the second wave is where they would want to build designs smarter or better. That's where we will be, playing a major role. This also happens globally.
That makes sense, because in my mind, India is importing a lot of electronics. So the government is thinking first, let's just slow down on the import. Instead of importing like 2% of our GDP of our imports as just mobile phones, let's make them here. And that would mean that we need to make those chips first. And then we would go down that.
And then you would innovate.
Then you would see we are making so many chips, but the underlying IP is coming from outside. So then let's focus on the IP. But you're saying that globally, IP is a big play.
Oh, definitely. Globally is an IP. And this happens especially in the last decade, where this concept of custom silicon or domain-specific architectures have become a default, right? The idea is very simple. I can't deploy an i7 processor for a smart bulb. That's a different class of process.
Sure.
Right. So everything people are going to go lower in their stack. They're going to start by innovating at the software, at the application, at the kernel, but now they have to innovate at the silicon to stand out. Right. So people will want a different AI accelerator. They will want different security protocols for, handle, the POS machines, right? Point of sale machines that you have. You want higher amounts of security there. You want to enable Wi-Fi there. You want to enable better experiences there. So each of these, you will be required to innovate at the silicon as well.
Fair.
When that happens, you have to design smarter. You have to design faster, because they will only innovate if the cost is justified. But if you say the cost is of 2 years of manpower and $5 million of IPs and toolings, and
then you will just compromise and take.
People will just be stuck. You will never see the next gen device if you're stuck. And that's what we are trying to do. We are truly trying to enable people to innovate by reducing and shrinking the timelines.
Understood. Okay, so I just want to. So we've spoken a lot about what InCore does, how you came here, and so on. And every once in a while, we spoke about this thing called RISC-V, which you explained in the beginning is a instruction set architecture developed in Berkeley and so on, which you guys adopted even before it was out fully, right?
Correct.
What does RISC-V mean in its global context, and why is it so important? Why is India focusing so much on RISC-V?
Amazing question. RISC-V, beyond an open standard, is an open opportunity, right?
Open opportunity.
It's an opportunity to play. So let me go back, right? Instruction sets were released much earlier. Right? They came back with IBM 360s, where the idea was, I want to have iterations on hardware and software independent.
Okay.
So I can keep building more better software, whether it works on Gen 1, Gen 2, Gen 3 of the device. So you can have two teams, but they always communicate with the same PDF. And that PDF tells you A for apple, B for ball sort of a thing. It tells you the instructions that you can use to build software and instructions that the hardware should understand. Now, once that was introduced, everyone realized that's the holy grail, right? If this is kept proprietary, you can control market. If you change this, you can improve performance. If you enhance this, you can get better software. And this became what people started keeping closed source, keeping as a secret.
So basically all the tools that chip designers use will use this ISA, right?
Yeah.
Okay.
So for example,
So I may not be actually writing an ISA, but anything that I use will somehow...
every time you write any code, it has to get converted to something we call machine code.
Which is written as per the ISA.
Yes. So that machine code tells you that if software has written add instruction, convert it to 10111, whatever the sequence is.
Okay.
That's the idea. Right? And
so if
it tells you what that behavior is.
So if a company is controlling the ISA, it's indirectly controlling all the tools, all the ecosystem, all the libraries.
Absolutely.
Everything. So basically it's like total control.
It's a monopoly. And that's what has been done. And there are three major ISAs that stand out today, right? There's the Intel x86. They're the pioneers in that space for desktops, for laptops in that space. You've got ARM, which is mostly in the embedded and the mobile phone ecosystem. They've dominated that space. And you've got IBM in the server class, PowerPC applications, right? None of these companies give you access to the ISA for free. If you get a chance to look at it, it's under massive license clause saying that you're not allowed to talk about it, you're not allowed to find bugs in it, you're not allowed to tell anyone that you've been working on it, and so much so forth, right? That's how secretly guarded this is. Even their own customers, for example ARM, they don't give them licenses so easily to the architecture itself. So ARM would give them the IP, saying that this is how it's going to work. It will not allow you to customize this. And RISC-V broke those barriers, right? RISC-V was inspired by the same problems. Innovation was blocked due to monopolies, due to proprietariness. And they said, okay, if you're not going to give it to us, we'll build it ourselves. That's what the Berkeley posted. And they came up with a very simple, very enhanced and future-looking instruction set. It's just 40 instructions. If you go to ARM, the minimum is those 200, 400, 600 instructions that you have to implement. 32 to 400 is the scale of how simple RISC-V has become. And RISC-V is open in a way that it's not copyleft. So in the open source world, there is also licensing terms there. For example, Linux is copyleft. It's a GNU license, which means if you make changes, you have to push them back in the open source.
Okay.
But RISC-V does not do that. It says, go do whatever you want. You can rebrand this as RISC-6 or RISC Gala, doesn't matter. You can go make money out of it. You don't have to pay us. You don't have to tell us. We are not liable for any changes that you do. Do whatever, go crazy with it. Right. And that's the beauty of it. And
but people do contribute back, right?
Oh, absolutely. It's one of the most thriving communities in the hardware ecosystem today. You've got every company, Google, IBM, Intel, NVIDIA, name it. They're all part of the RISC-V consortium, except ARM, for sure.
Because it's an existential threat to them.
They could have accepted, but it would be a very difficult battle internally for them, I believe. And by RISC-V gaining adoption through Google, through Facebook, through NVIDIA, through IBM, I think it's just set it in stone that RISC-V is here to stay. Right? It's not going anywhere. And because it's open, it's going to survive all threats of monopoly.
And you were part of the international RISC-V community as a operator.
Yes. I was, so IIT Madras was one of the founding members of RISC-V. So because we adopted before RISC-V was there, we were amongst the first 10 or 12 entities across the world who became the founding members of RISC-V Foundation. Personally, at InCore, I was also contributing as the vice chair for the compliance of RISC-V. Basically, if you have to use the trademark for RISC-V, claiming that your chip or your product is RISC-V compatible, you have to pass a bunch of tests. And that entire test suite, infrastructure, automation was all built by InCore today.
So in your period that you've been associated with RISC-V, is it something that's grown? Are there actual chips?
Oh, definitely.
Okay.
Yeah. For example, there's just an article yesterday. NVIDIA has shipped more than 1 billion RISC-V parts just in 2024.
Nice.
So it's
What does it mean for a country? Like, why is RISC-V India's ISA?
I was just getting to that. So as I was saying, RISC-V being open gives you the permission to play, right? In a space that you've been locked out for decades, for geographical reasons, for talent reasons, for brain drain and all of that. All the smart people have been going abroad, or we've been a services sector. RISC-V has opened the opportunity to create, to innovate. And that now becomes a way to segue into what we were talking earlier is the fear and the paranoia that the strategic sectors have. They can now truly control. They can ensure that a chip does not have a backdoor. Right? You are now completely in control of the entire loop from spec to production. Right? And that becomes an important factor because you can now build something that is more India specific. See, I think the problem that we've been facing is we keep importing foreign solutions for Indian problems, right? And professor once told me this amazing story, right? He said, if you go to the US, right, the tap water, it's the same water that goes into your sink and it's the same water that goes into your washrooms and what you drink and everything. It's all from the same source. Imagine if the campus did that in India. It wouldn't fly, right? You would have Brahmins or you would have these religious folks who would come and say, oh, how can I use the bathroom water to, do my religious activities, or how can I drink that water? You need separate sources. In that context, I don't think applying a foreign solution to Indian problems is just going to fly out of the box. At some point, you have to innovate for Indian problems. You can only do that if you control the ecosystem.
You have to build ground up.
Exactly. So, for example, what Bhavesh Agarwal did with Krutra, he said, I own the e-bikes, I can build stacks, but he now wants to control silicon. Right? He wants to control data. Why should it go to the Europe borders, and why should the data centers be there? Why can't it be within us? Why should I share my data to anyone else? Because this is Indian stuff for Indian problems, for Indian solutions. And we need a lot more resources for us to innovate in that space.
Fair enough. Nice. This has been a great conversation. And of course, Professor Kamakoti was here. And we spoke to him also about RISC-V and about how India needs to be self-sufficient. It's not enough for us to say that we have built a Shakti processor, so we know how to do it. It also needs to go into our power plants, and the commercialization has to happen. And it's not enough to say that we can build CCTV cameras on our own. We have to actually go and do it.
Yeah.
And so that's amazing that you're also you are part of the journey where at a university level you are thinking it through, but also part of the journey where it's actually going to industry and the commercialization is happening. And long journey.
Oh, definitely. It's a fruitful one. It's one bearing a lot of good memories, a lot of good learnings, I would say.
Would you advise young people to get started on the same journey now?
Oh, most definitely. I think the world is much more accepting than it was a decade back. I think the challenges we faced have reduced today. I think the government is much more aware. The investors are much more aware of semicon, of startups coming out of India.
You mean the problems that a startup founder would have?
I think we spend a lot of time educating investors, educating the government as to why what we're doing is of strategic value, why this is of commercial value, why this has to be the next big thing, right? The awareness has grown, the access to information has grown, people are participative, people are forthcoming. The DLI, for example, is an amazing initiative, right? I mean, we've saved millions of dollars of tools spent. So otherwise, with the 3 million seed round, it's impossible for us to have such an ROI. We are definitely much higher on in terms of output when it comes to the dollar invested. So
per dollar
returns are much.
Much higher. So even investors who are in Europe and US.
So, although to the young people, I think the biggest comment that I would give is, or suggestion I would give is, stop fearing failure. You would be surprised the number of people who are watching for your success. Right. It is amazing that the patriotism, the Atmanirbharta is actually there. It's people are forthcoming, people are willing to be your well-wishers, even if they've not seen you. As long as it's in India, as long as you're willing to put in those hours, those efforts, and don't be afraid to ask the silliest and the stupidest questions. You're not an AI. And AI can learn the entire BTech degree in 10 minutes. Humans have to go through it, right? It's impossible to do that. So don't fear the effort. That's what I would say.
To that student in university now who wants to go abroad, who's going to his professor now and taking that reco letter like you did 15 years back. I know you're saying it, but do you think that, how do they build the courage to sort of stay here and build, knowing that maybe a US life is easier?
That's
I mean, especially in semiconductors, right? Because in semiconductors, the bulk of the industry is in the Valley and whatever in the US.
No, definitely. This is a conversation I have more often, even today, because we hire freshers a lot. They have these dilemmas. Okay, maybe I'll work for 2 years and then I'll go to the US. So I still have the same conversations. And to be honest, I don't think there is one answer that I can give. But society pressures definitely play a major game, right? Do you have commitments at home? Do you have pressures which warrant you to earn? Because doing a startup here, you have to have the courage to go through a lot of hurdles financially, society-wise. You're going to have constant, chachas in the next door saying, oh, you've not done this, oh, you've not hit this milestone, you don't have a kid, you don't have a car, you don't have a house. Those things still exist. Right? It's going to be a journey which is going to be rewarding at least 5-6 years later. It's not instantly rewarding. So to the guy who really wants to go to the US, I would say, if you truly believe that an IIT or an BITS or any top tier 1 institute can't give you that here, maybe yeah, because it takes a very different mindset to be here, right? So if your goals are not as ambitious, if your goals are not local, if your contributions are more to just tech rather than people, maybe the US is the right place for you. Right? You want to push boundaries in a very different region. But personally, I would tell them to shred that recommendation as soon as possible.
Nice. I wanted to hear you say it, and you sort of like said, oh, there's a lot of context. Maybe it depends on you, but you finally said it.
I don't want to make a blank statement, but yeah, I think there is enough opportunities in India, but there's a struggle as well.
Sure. So it's difficult, but shred that.
It's rewarding.
Yeah.
For sure.
Shred that and stay here and build with us. That's fantastic. Let's close with that. But since you mentioned it, I want to bring it up that you just recently also had a child. So you're a father now. Yeah. And that's a different kind of life.
Absolutely.
How has it changed your mindset?
It's no, thanks for asking that question. It's not a recipe I would recommend. Being a startup founder and a father is a bad mix. You're constantly in hangover from one or the other. I think the mindset changes. I've been a techie for a good more than a decade of my life, right? I'm extremely good at it. I know that I can build processors, I can build solutions, I can sell them, I can make money out of it, because I live, breathe, and eat that. And once you have that little bundle of joy in your arms, you have now hit with different responsibilities, different gratitude, different content, different love, for that matter, right? And now it's a balance. You're constantly striving for the balance where now the needs are no longer just InCore. The needs also come in from your loved ones, from your family. As a father, you want to set an example, but you also want to provide at the same time. So it's a wonderful journey for sure, and I'm hoping to see what more I learn from this. Just been 6 months. It's been overwhelming for sure.
You know, when I was also running a startup when my kid was born, and I felt that the one thing that it made me was, it made me a little more impatient for moving things forward. Like earlier, I think I was a little more patient with my startup, and now I'm like, no, let's do it now. Let's do it now.
Yeah. No, I agree. I completely agree.
It's like time is ticking now.
Yeah, I was of the mindset at least 8 months back, 9 months back. I was, we should spend more. We should do this. We should do that. But yeah, fatherhood hits you differently. It's
Yeah.
You're not the only guy in the room. There's someone else hanging off of you.
Yeah.
I mean, yes, you have a relationship with your employees, but it's very different when your kid depends on your decisions.
Yeah.
But it's brought a positive aspect.
Yeah.
I think it brings a lot more maturity instantly. Right? You're now thinking 4 things ahead, rather than just in that isolated bubble of, I want to make more money, I want to make more impact. But it's doing it properly, doing it organically, doing it with a long term in mind. I think those are the kind of things I've started appreciating of this new phase.
Nice. Thank you so much, Neel, for sitting with us. I learned a lot, and I hope it was. I hope, Deepak, I hope you have covered all your points. Thank you so much for them. This is Neel's colleague Deepak, who wrote down a lot of points for us to discuss, and it really helps us a lot. Helps me a lot because I'm not from the industry, and of course you are. But it helps me understand what this industry is about. So thank you, Deepak, and I hope we have done justice. To those listening, thank you for listening in. Please share, subscribe, press the bell icon and leave a comment. You can check out InCore and what they do on their website, or reach out to them on LinkedIn. Thank you so much.